Good morning. This is Noah Gutierrez with Diversified Product Development, and we are doing a presentation of a LineWise product that we offer today, known as the LineWise Buddy Bushing. So we welcome you this morning. As previously stated in the last webinar, we have two of these webinars that we do back to back from Wednesday to Thursday every 3 weeks. And this one we're doing the buddy bushing, and we do this at the two different times to give everyone the flexibility to be able to attend on Wednesday or Thursday if it works better for them in the morning or the afternoon. So again, we do this every 3 weeks on a different product or a subject of your choice. And so we want to hear from you as far as a product or a subject that you'd like for us to discuss. And so we welcome everyone that's joining us today. And so we're going to go ahead and proceed without delay. We just want to be respectful of everyone's time. And so we're going to go ahead and continue. So first thing we like to do in getting started with the webinars is to be able to take you to the website and show you where you can find this product. If you're a manufacturer's rep and you're viewing this webinar this morning, then we want you to be able to find this link and share it with your customers. We also want to be able to allow our customers that are visiting this morning in this webinar to be able to go to this same place and find it and share it with your colleagues as well. So as always, we go to line-wise.com, as you can see there in the upper left-hand corner. And then from there, you go over to the utility section. And then from there, you go down to utility transmission. And currently it sits at the upper left-hand corner. And from there, you're going to be able to find everything that we're going to talk about today. Now, the way I like to do this, as usual, is I'm going to go over to a PowerPoint and share some information that we have there in the PowerPoint. And then we're going to come back to the website and see some of these documents that have information that we're going to cover in the PowerPoint today. So at this time, we're going to go to switch over to the PowerPoint and go through that information. I want to thank everyone that's also working in the background. It's not just me doing the work here. We have our marketing person, Heather Still, that's helping here in the office. And we have Samantha Aguilar also working to help make this as smooth as possible. I mentioned yesterday that we are doing some different things than what we've done in the past. And so we want to hear your comments and also see what ideas you have of how we can make this the best possible webinar for everyone to get something out of it. So we're going to go ahead and dive into this PowerPoint that we have here. So what we have here on the screen now is just one of many structures that you might be able to use the buddy bushing on. And so in this particular case, you can see we're running double circuit bundle conductor on each side, the 3 phases on each side, that is. And up at the top, you can see the static line. So it's pointing towards the 3 conductors or 3 phases, and the static line that you can see there at the top. This is typically where the buddy bushing is going to be used. Now, up at the static line, there's some hardware that holds that static line into what people call a vang hole. That's V-A-N-G. You may have another term for it. And then the same is true with the conductors. The conductors are going to have their insulators. And then the insulators, at the top of the insulators, there's going to be some hardware that you would insert into the vang hole as well. So that being said, this is where the hardware is going in to that hole is where this problem is occurring. And we're going to look further or deeper into what that problem looks like. So here you can see an actual application where this has happened. Here, this is where the static line is attached using a shackle going into what we call the vang hole here. And you can see that over time, what has happened through wind-driven vibrations, the shackle just moves back and forth, causing this groove or slot or hole to form in the bottom of this larger vang hole here. And over time, what happens is if this isn't caught on time, this is going to wear to the bottom of that hole, and in some cases has dropped out of the air. Once again, this is not just on the static line hardware, but it's happening with the conductors as well. In the field today, I would almost call it 50-50, where 50% of the buddy bushings that we've installed are being used with the conductor hardware, and the other 50% is with the static line. So this is something that happens, and then when the conductor is not, or the hardware is not using the buddy bushing, and this problem continues to occur or proceed, then what happens is these lines fall out of the air and fall into the trees, maybe fall to the ground, and in some cases have even caused fires. And so the buddy bushing is a product that will eliminate this problem that we're seeing in these photos here. Now, this product was developed by an electric utility. They hold the patent today, but have licensed Diversified under the LineWise product brand to manufacture and sell these products to other people that have the need or that are running into this same problem. The buddy bushing here, what we're seeing in this slide here is a rendering that we've done where we've taken one form of how the cross arm where the hole is located and showing the buddy bushing in place. And I say one form of it because you from your particular area, you might think that this is the same everywhere. The way that you do it is the same everywhere else. But this is from our experience, it's always different applications. And we're going to see a few of those different applications where the buddy bushing has been used in the different cross arms that are out there today. So in this one, you can see in this rendering, we have this arm with the hole in it, and then a buddy bushing that is installed into this hole. And at the bottom, you can see where that groove was being formed by the hardware from the static line or from the conductors themselves. The buddy bushing itself is composed of three components. You have your inner hub, you have your outer hub, and then your spiral lock ring. And so what happens is from the previous one that we saw, you would install the outer hub first to take up the space inside the hole, and then you would install the inner hub, and then you would install the spiral lock ring. Now, you'll see that the inner hub is composed of 17-4 stainless in this particular application, and then the outer bushing is composed of 416 stainless. Now, it may be in your particular application that our engineering team may determine that those materials may have to be different. That is something that we'll determine by the information that you would supply on your buddy bushing form. Now, that can be found on our website. We're going to go and cover that a little bit later, as previously stated. Something that I want to point out here as well is the spiral lock ring itself. And we had a particular application where they were installing the buddy bushings from a helicopter, and they felt that it was easier to use the traditional snap ring, where you use the snap ring pliers to be able to install the snap ring. So do you have to use a spiral lock ring? No. What's nice about the spiral lock ring is that there's no tools involved. Whereas with a snap ring, you would have to use snap ring pliers. But to us, it doesn't matter. What you need to make your job easier to install these buddy bushings is what we want to supply to you. So you just simply have to notify us of what you're looking to use as far as traditional snap ring or the spiral lock ring. In some cases, and we'll see in a QA sheet that we have at the end of this presentation, you'll also see where a question where do you have to use the spiral lock ring, or do you have to use the snap ring? And the answer is no. It's really up to you. But in most cases, it has been used. Here, you'll see the wide clevis. In this particular case, it may be where you would want to use the snap ring. They also have the straight clevis applications as well, which kind of closes in on the buddy bushing. In that kind of application, you may be able to get away without using the snap ring. As long as you're comfortable with it and we're comfortable with it, we see no reason why you would have to have the snap ring. But once again, it's user preference and what your engineering department may require. The weight of the hardware and the lines cause the inner bushing to rotate, eliminating the sawing action. So as mentioned, and I'm going to go back to, then we'll use this one right here. We said wind-driven vibrations is what is causing this to happen. And so you can imagine the static line or the conductors down below with the wind blowing back and forth, or the wind blowing in a certain direction. It causes the hardware to move back and forth, which causes this pin to move back and forth. And without the buddy bushing in place, it causes that sawing action to happen on the bottom of the vane hole, as we were mentioning. And I've always said this, and I believe it's 100% true, and that's that as long as you do not have the buddy bushing in place, and as long as one piece of material is moving and the other one is not, you are going to have something wear out. And in this case, we see it happening at the bottom of this vane hole. I don't care what they do in the industry without the buddy bushing and without this rotation feature, you're not going to get away from that problem that we're seeing in the bottom of the vane holes. So that is something that is part of this product that keeps that problem from happening. You can, and another thing I mentioned yesterday as well was that the type of material that we use on the buddy bushings, you know, it keeps the two different types of material keep the material from galling against one another. The other thing that happens is it's the type of the material that we're using and the heat treating process that it goes through that keeps this from problem from happening as well. And so you might imagine that if they could heat treat an entire structure and use the same type of material that we're using, maybe that might work, but still it would even eliminate, it would still not use, it would not have the rotating feature that we have here. And so there's just a bunch of different things that's happening in this small little product that you can't even imagine that is keeping this problem from happening. And so once again, it's just some pretty neat features in this one little product that we offer. Engineering provided us with some FEA, finite element analysis, that show how the buddy bushing is taking the stress and what's actually happening in the field. So what you're seeing here is a new arm without the buddy bushing installed. So this little circle that you see here in the midst of this big circle, the big circle being the vane hole that I mentioned earlier, and then this little circle here representing the pin for the hardware that's going through the hole. You can see that the bottom of this hole is taking some high stress here in this red yellow area here. And that is why you're seeing that groove starting to form in the bottom of that vane hole. In this next slide that we see here, we see that stress is now going into the buddy bushing itself. And so what's happening here is we've removed all of the stress out of the bottom of the vane hole and now placed it into the buddy bushing. Now, you might say, well, Noah, why won't this same problem happen in the bottom of the buddy bushing? Well, it's because now we have that rotation feature. We have the stainless steel that we're using. Engineering has looked at this in such a close way that they're going to determine what material is needed to be able to take this stress and eliminate this problem. Georgia Power had installed these buddy bushings, and I believe it was a 2-year period that they left them in the air, and then they removed some of them from service for inspection. And what they had found was that the sawing action had been eliminated, no more wear had gone into these structures, and the buddy bushing had looked just as well as it was in the day that it was installed. So we know the buddy bushing is doing its job. And we're going to also look at some slides later that say how it's been tested by a third-party company as well. Here in this slide, we see where one of the bushings, the inner bushing, has been removed to show that all the stress is going into that inner bushing. It's not in the outer bushing, and we removed the stress from the vane hole and the cross arm itself. The buddy bushing installed on the cross arm with a wear in the bottom of the hole. Note that the buddy bushing is now taking all the stress. Even with substantial wear, the buddy bushing makes the worn cross arm stronger than a new cross arm. And it's not said in this particular slide, but it increases the strength by 25%. And we'll see that somewhere else. This is the buddy bushing form I mentioned that we're going to look on our website later. So I'm not going to dive into that in this particular PowerPoint, but we're going to see that a little bit later. Some frequently asked questions. Can the buddy bushing be installed on new construction? Absolutely. We have one electric utility that is in the middle of doing that. They got some buddy bushings that they've ordered, and they'll go in on some new construction as well as worn out vane holes as well. What kind of material is the buddy bushing made out of? It's a corrosion resistant stainless steel. Other materials are available for specific applications. And this is something that if you do not choose from our existing lineup of buddy bushings that we're going to look at on our website a little later today, you can fill out that buddy bushing form that I mentioned that we're also going to take a look at later. And you'll also see there that you're going to put in loading that you're seeing and ice cases that you wanted us to consider. And our engineering department will look at that, and within 2 weeks get back to us and let us know what kind of material, or they'll know what kind of material they're going to need in order to be able to pull this off. So it's not always the same as material as mentioned in the previous slide. It may be something different. Has the buddy bushing ever been lab or field tested? The answer is yes. The buddy bushing has been professionally lab tested at NETREC and has also been installed and field tested by Georgia Power on transmission lines. Another question is what other customers have used the buddy bushing and can give me their opinions. So we've had this request many times This list that is shown here is not necessarily the latest list. In fact, I know it's not the latest list, but it shows some of the customers there. We won't go through naming all of them, but if you want to talk to someone about that, all we ask is that you give us a little time to give them some forewarning and say, hey, is it okay for us to give out your contact info? So this way you, an interested customer can reach out to you to ask the question. So it can be done. Just let us know if that's something that you'd like to do. What loads are the buddy bushing rated for? A load requirement. See, load requirements will vary based upon your application. Every application will be evaluated by experienced LineWise, a LineWise engineer to ensure the load rating will be greater than your requirements. So some of the things that we've seen in some cases is where the electric utility will give us a load rating that is way heavier than what the structure is used to conceive. And our engineers have looked at it and have come back and said there's no way that the structure can even be standing with this kind of load. And so we go back to the customer and they say, oh yeah, we just made up something. And so sometimes that happens, and we know that happens, but we're asking that you give us the best possible load case scenario that you think needs to be taken into consideration, and LineWise engineers will look at that for us. Does the buddy bushing need to have a snap ring? We talked about that earlier. The answer is no, and we can even use different snap rings. Another question is, what kind of analysis has been done on the buddy bushing? It's an ultimate tensile strength test was performed at NETRAC. I'm going to shorten that up. All applications will be evaluated by LineWise engineers. It says, how do I know if the buddy bushing will work for my application? The buddy bushing has been tested and field proven to work in any application or field in which it is desirable to reinforce and protect the hull from additional wear. All applications will be evaluated by LineWise engineers. We also, I didn't mention this yesterday, but I just remembered, EPRI, which is another test facility, is having requests from other utilities to test the buddy bushing. That is something we hope to be able to provide and update everyone with here in the near future. The buddy bushing, is it patented? The answer is yes. The patent is 8399770B1. And of course, if you want more information about the buddy bushing or want to know how you can get more information, of course, you can call this number here on the screen or email me at noahg@diversifiedproduct.com, and we'll be glad to answer any other questions for you. Two more slides that we have left before we go back to the website is some other places where we've seen wear happening is on the hardware itself. This particular application was happening out in California. So you can see on these two slides there in the middle of the pin, and also in the middle of this shackle here, you can see where where hardware was being used together, locking them together to get the hardware to face a certain position is what my assumption is to when it came into contact with the bang hole. And so this is where the hardware itself was beginning to wear. We never actually provided the buddy bushing for this application. The customer never moved forward, but we are confident that you can place some form of buddy bushing, some iteration of the buddy bushing in between this, and then run the hardware above the buddy bushing in between this hole and this area here to keep that wear from happening. So if you're seeing this type of situation in your area, give us a call. Would love to discuss it with you and have the opportunity to supply buddy bushings for this particular application. Now we're going to dive back into the website and find some of this information that we mentioned earlier. So the buddy bushing brochure, you can download this from our website and share it with your other salespeople. If you're a manufacturer's rep or a reseller and you're on the call this morning, you're able to take this link right here and share that in an email to your other salespeople to show them the buddy bushing brochure. If you're a customer on the call this morning and you want to share this with your counterparts and other people in your company, again, you can copy this link, paste it into an email and send it to other people in your company. So this is a real good brochure that we have that shows some of the information that we saw on the PowerPoint today with the worn out vane hole, and then showing with the buddy bushing installed. It also shows another application that we've used for the buddy bushing. So one of the things that we run into, and you'll see it in one of the next things that we go to pertaining to the different sizes of buddy bushes that we have, is somewhere about an inch in diameter on the vane hole. It gets a little tough to use the buddy bushing, especially with high loading or what orientation the conductors are to the vane hole itself. And so at about an inch diameter and below, it's going to be hard to use the buddy bushing in that exact same hole. So we came up with an idea. One of our engineers had this great idea of being able to come up with this plate that you see here in orange. And what happens is, in this particular application, and it's been used before, and it's been used with two different customers at this point, is what they do is they bolt on this plate, for lack of any better term, I call it a buddy bushing plate. And you bolt this onto the existing hole. It's torqued to a specific torque that the engineer will, LineWise engineer will supply you with. So that this way it keeps this bolt from moving in this hole any further and causing any more wear to occur. And then this bottom hole, you would install this buddy bushing in. And then from that point going forward, you would now install your hardware into that bottom hole. And now you get all the features of the benefit in this new hole. Now, what's the downside to that? It's going to drop some distance from the existing hole to where this buddy bushing is at now. Now, depending on what your cross arm is like and what that plate is like on the end, it's going to determine how far that drop's going to be, but it's going to be anywhere within 1 to 2 inches is my guess at this point. But that's something we can look at as well for your particular application. So again, we've talking about where we've seen different applications for the buddy bushing. It's not always just that plate that I was showing in the PowerPoint where it has that angle that comes over. Sometimes it's like what you see right here on the screen, where it's a piece of some kind of tubing with a plate on the end. Sometimes it looks like this particular picture here on the brochure. It's always something different. You know, again, we've seen two angles back to back with the hole going straight through it. So whatever your situation is, just because you don't see that same application here doesn't mean you can't use the buddy bushing. Give us a call, send us pictures. Let's talk about it first before you completely erase the idea that you can't use or come up with the idea that you can't use the buddy bushing. The next thing is once again something new, most recently added to our website for the buddy bushing, thanks to Heather Steele, our digital marketing specialist. She has recently updated the website, revamped it to have all this good information on the buddy bushing. I think it was just late last week, I looked at it, a test run of this, and I was like, wow, you know, I didn't know we already had all this on there. And so it's great work, and we thank her for that. But what you see on the screen right now is something, once again, that you can find on our website. That's the link I just clicked on. And it shows buddy bushings that we have produced to date. So one of the biggest complaints that we get from customers is like, man, I got to fill out this buddy bushing form, which we're going to take a look at next. You know, there's so much information that we're requesting. Well, if we're going to meet your requirements, we have to know that information. But sometimes the time just isn't there, and perhaps you know most of the information and you're comfortable looking at this chart on our website and you say, you know what, yeah, you know, I could use it within, for example, this first one, vertical load of 560 pounds. And then the hole diameter, you know, which is shown in red up here, right? This red dot means everything that's shown in red here in this column. So the hole is 0.9375. You know, so if you have a vane hole that diameter and you can deal with 560 pounds and everything else within that same column works for you, then yeah, call us, say, hey, I want part number 71395 and I need 100 of those things, or 1,000 or 500, whatever your quantity is. Then we can get it on order for you. So I don't want to give you the false impression that all of these are sitting in stock at our facility. Maybe that's something that we may consider at some point for the most common ones, but we haven't figured out what the most common is going to be just yet. But for now, at least what you're going to be able to save yourself is that 2-week turnaround for the engineering department to look at that and get back to you to say whether you can get it done or not. Maybe you may look at this and say, my total vertical load is going to be 9,000 pounds, and the hole is 1.5 inches, and everything else within these columns that are color coded works for your application. You can call us and ask for that same one. So we're trying to make it as easy as possible on you and cut out some of the lead time. But once again, you can share this by copying this link and send it to whoever you would like to share that with. If it doesn't fit within that particular, one of those particular applications that we've done before, then what you could look at is the allowable wear form and get that pulled up. And this will show you everything that we need to know, from the conductor running in this, or let me rephrase that, with the hardware running in this direction or this direction that you see here. All of that makes a difference in the LineWise engineering department running their calculations. And so you go in there and you fill this form out, and then you get it back to us, and we'll get that over to engineering, and they'll run their calculations. When it's all said and done, you get a document that has the engineer's seal, or professional engineer's seal of approval on that. And it will even tell you what the minimum amount of thickness is that is allowed in the material for the worn out hole. So that's this material that you see here. That's that F dimension that we would indicate on this document. And then when your linemen go back up and install this buddy bushing, they'll be able to take that measurement and determine whether that cross arm is able to use the buddy bushing or not. You can also download the need track report that we were mentioning earlier in the PowerPoint. I won't read all of this to you today, but you can look through here, download that, look through there, and see how it was tested at need track, so that way you can get a better comfort level as to if the buddy bushing will work for your application, and also let you know how it was tested. You can get all that information just right off of our website. The last thing that I want to share is another new document that we've uploaded to the website most recently, and it shows a cost-benefit analysis document. So the buddy bushing is going to have different pricing points depending on how many you order, and also, well, it basically comes down to quantity. And if it's anything less than 50, there's going to be an engineering charge that we're going to need to apply to that, because we've got to recover that and what we're putting into these particular buddy bushings. And so far, what we've seen, customers, when they were the best way to say that is the repeat orders that we're seeing is based upon a customer that ordered a second go around, a third go around of those buddy bushes that they ordered the very first time. So far, we really haven't seen an application where some other electric utility had the same need as someone else in another location. The pricing point is going to be starting at roughly around 150 each at 1,000, and then it works. The price gets higher as you order less. So at around 50 to 100, you might be looking at $200 and something per buddy bushing. Again, resellers get discounts and all that good stuff. So, but in the cost benefits analysis, I won't go through the trouble of reading all this due to time constraints here today, because I want to allow some time for questions if there's any questions. But in this document, basically what it's going to show is all the benefits and the features of getting and using the buddy bushing. The long story short, some utilities let the maintenance go for so long that needed to be done, and there are actual stories, if you go research them yourself, where PowerPoints I'm sorry, PowerPoints for Google. You can find them on Google and show where conductors fell out of the air and into the trees or onto the ground, and the ground was dry and sparks started fires. And in one particular application out in California, it shows where 85 people lost their lives. That is something where the buddy bushing could have prevented those kinds of things from happening. That rotation feature, keeping that wear from happening and keeping the structures from failing and dropping power lines. The price that you would pay for a buddy bushing will pay for itself in the years to come. Sorry. In years to come. Sorry, Siri thought that I was asking for her. But buddy bushings and the price points of the buddy bushings will pay for themselves for many years to come. There's no price to pay for replacing a person's life because of a fire that was started due to lack of maintenance. And then looking at the grid in the future, yeah, it made this where in some instances has happened over a 40 to 50 year period. In some cases where winds are real high, like say in California or on the western states, the wear has happened and sometimes in 2 to 3 years or maybe 5 years. But by not using the buddy bushing because they don't want to, they may not want to spend the money now, you're going to spend it later on down the line, having to go through and replace the arms once again and send guys back up in the air to pull off the worn parts and replace them. We've heard of where they unbolt certain parts of the structure to remove pieces to replace the worn out part, and now the towers start to move back and forth. And at the ground, that might not mean so much, but when you're up in the air, it means a great deal. And one part I will mention off of the cost benefit analysis here is one of the last one, overall cost reduction. It says a project that consisted of 132 towers with 400 buddy bushings being installed over a 14-day period. When the project was complete, the IOU added up the cost of the buddy bushing and new hardware plus the man hours expended and came up with a cost savings of $1.2 million over a traditional tower repair, tower repair methods. So don't put that off till later. Take care of the grid for future linemen, future crews, and more importantly, for the lives of people that could be at stake due to failed towers. So that being said, we want to open up the call for any questions that you might have. I see that we have our CEO on the call today. He might have something that I have missed. Typically, I'll bounce stuff off of Dave Packenbush in a call like this to bring up anything that I might have missed. But Dave is out in the field this week doing an in-service on one of our products known as an IWP, which stands for Insulated Work Platform. So Ray, I'll ask you if you have any questions or not questions, but anything that you want to point out that I might have missed. I welcome you to do so, sir.
Well, I don't get a chance to sit in on these very often, and I wanted to do that. Very impressed, Noah and Heather and Samantha. You've done a great job, provided some good information, and I love it. I think this is the way to get information out to more of our customers. Man, if I had a transmission line, I'd put these on, but don't have any transmission lines myself, but glad we're providing them to others. Everybody, thank you for being on the call.
Thank you, sir. Anybody else that's on the call today have any questions or comments? Maybe you've, in one of the calls we had before, we had one of the customers on the call. I don't know that we have them on the call today, but if you're a customer that's used the buddy bushing and you would like to make a comment as well, if you've sold some of these buddy bushes before, you think I may have missed something, your manufacturer's rep or a reseller, and you want to make a comment or have any questions, please feel free to share at this time.
So Noah, this is Rick Kennerly. I have a suggestion for you. It was a good presentation. One of the root causes of failure between the joint of the shield wire and the hardware is due to not only corrosion, but it's due to electrical failure. And what I mean by that is as that connection corrodes, the shield wire is used to transfer current from lightning strikes and fault current events that take place. So if you looked at some of your photos, and I've been involved in this with several electrical engineers in past years, that joint, as it gets more and more corroded, you have a higher resistance. So as current flows through that resistance, it creates a voltage drop. That voltage drop creates a heating component, especially during a lightning strike. And you have the reliability component of that goes down for the system. So you have an increase of voltage from the tower base over the insulators, which cause what they call flashover. When flashover occurs, you have an outage during that event. The buddy bushing would prevent that from happening if the corrosion component between the bushing and the steel were to be reduced. So I think there's a play here from a sales perspective with a reliability slide to take care of what I just said. There may be some additional testing to be performed here based on the amount of current that could pass through the buddy bushing from the steel and the hardware, if you follow what I'm saying. But most of those failures on a shield wire interface, which you were showing several of them there, it's not only the insulator to the hardware, to the steel, it's the shield wire. That would be, I think, from a sales perspective, one of the first things to attack for most of the major IOUs, because there's a safety component there. When the guys are out working on a de-energized line, they rely on that shield wire to carry the current from an inadvertent energization that to get back to the source. And a lot of times the only way they can do that is through that connection. So if you could demonstrate that connection maintains a low impedance path, then obviously it increases the safety and increases the reliability for your utilities. So I'd be happy if you want to send me that slide or send me that presentation, though. I'll be happy to add what I'm talking about to it, and then you could pass it up through your engineers work for your company. I know the utilities like FPL, Duke Energy, even Encore right there is really in tune with what I'm now talking about. So by adding that component to the presentation, I think it would add a lot of value to the product.
Information is very, very much appreciated, Rick. I can't tell you how valuable that is. And we will send that off to you. Samantha, who's on the call today, will get some information over to you before the end of today. And again, thank you very much. That is very good stuff. I was writing down some notes here so that way I don't lose sight of that. Thank you again, Rick.
Yes, sir.
Yes, sir. Anyone else with comments or questions, information like Rick just did or share?
I have one comment. Rick, thank you very much. That is huge, huge component in what this buddy bushing can do that I didn't realize. So we are learning all the time. I did notice that I think we've got at least one contractor on here, probably Chris Kiernan, but for contractors, the utilities are going to make the decisions on whether they want buddy bushings. But I think when you take something like this to a utility that you're doing work for, you're adding value. You're helping them become aware of products and things that will make their grid a better grid. And by you possibly taking it to them, it helps educate them. I know we appreciate it, but it adds value to your relationship with that utility.
Definitely. Anyone else? Okay. Well, if there is no one else, then we want to thank you for joining us this morning. Be looking for another invitation. Be looking on the social media sites for our next virtual demo / LineWise webinar in the next 3 weeks. Again, we give 2 options, Wednesdays and Thursday of that same week, one in the afternoon on Wednesday and the other one in the morning like today on Thursday. We look to hear if you have a product that you see on our website. I encourage you to go to our website, check it out. look for a product on there. If you see a product on there where you want to know more information about that particular product, please give us a call and or shoot us an email. Let us know what you'd like to see. Thank you again, and we look forward to having another webinar here in the next few weeks. Take care. Until next time.